Hi there, I'm Matt Snyder, and I'm here to talk with you today about Azure Service Fabric and building and running microservices at scale. I'm very excited to be here. I'm very excited to talk about Azure Service Fabric. I've been a program manager on the team for about 7 years now. I'm always excited to talk more about this thing that we've been building and delivering to you. So when we talk about Service Fabric, one of the most important things to think about is this transition that's going on between monolithic architectures and microservices architectures. And if you're not familiar with that, we can talk a little bit about it. In a monolithic approach, typically you had one big application, had many components inside of it, but it was fundamentally deployed as one big unit on several individual machines. And you kind of dedicated a machine to that instance of that application. This worked great, but it had some problems, particularly like if one of those components inside of that application was consuming more resources or required more scale than the other components. You didn't really have any option except to, stamp out a whole nother machine with that application on it again. This sort of structure is something that we're trying to get away from when we talk about microservices. So in a microservices architecture, each component is really its own little service, and there's a whole bunch of benefits to doing that. You can scale those services independently, you can upgrade them independently, you can monitor them independently, you can write them in the language that they're best designed or that the problem that component is solving is best suited for. You can break that application that was previously one big monolith run by one big team into a whole bunch of smaller, kind of two pizza teams where just a couple people work on their area of expertise and then can roll that out without disrupting the overall application. Another way to think about the change that's going on is that, when we had monoliths, we had this problem of state, and there was usually some giant database in the back somewhere that was the arbiter of truth, the thing that held on to all of the state. So you'd have your web front end, you'd have your business logic, you'd have your caching layer, but then fundamentally there was some data tier. That was where you got all of your real high availability, all of your true reliability guarantees, all your consistency came from that one big store. In a microservices world, we have to solve the same problems, but you can't necessarily have that giant store behind you. So you get a microservice for your stateless presentation layer, your web front ends. You might have other stateless services doing things like monitoring or aggregation or providing views. It's totally fine, of course, if you have a little microservice that still talks to some external store, because not everything will exist in this world. But something that we can do now is you can take that big monolithic store and you can break it up into stateful microservices that actually have the business logic and the state and the data with them that they need in order to do their job. And in Service Fabric, something that's interesting is that a lot of the things that you previously had to go to that big external store to do, like get HA and scale and partitioning and consistency of your data, we can actually do all those things inside of those stateful microservices. So that's a big benefit and something that lets us actually move things from this monolithic world up into services. So this is all very nice, but what does this have to do with Service Fabric, right? What is Azure Service Fabric doing and what is it going to give to me? Well, when you talk about Service Fabric, there's a whole lot of different capabilities that Service Fabric brings in terms of a platform to this world. So because we give you programming models, because we give you high availability, because we give you the ability to balance and allocate resources in your cluster, we give you the ability to monitor all these individual microservices. All of these things really make writing an application in a microservices way feasible, because if you had thousands and thousands of components that you all split up, you couldn't really run them without some platform to help you do it. And furthermore, it'd be really hard to write. With Service Fabric, if you take advantage of some of our programming models, which we'll talk about later, you can actually write microservices that are tailored for this environment. Rather than trying to figure out how to do all these things from scratch, the programming models really help you. The other thing about it is that Service Fabric is a platform, and we take care of hiding the environment from you. So whether or not your Service Fabric cluster is running in Azure or some other cloud or even on premises, you get all of these benefits, and the application logic doesn't need to change. When we think about Azure Service Fabric, a frequent comparison is kind of how does it feel versus Azure Cloud Services, right? How does it feel versus how I program things today? And in Azure Cloud Services, you kind of have one type of code targeted at one type of machine, and then you might have a whole bunch of different types of machines or roles that you have to deploy and manage in order to make your service really work. In Azure Service Fabric, all the machines are just a pool of resources, and you can segment the workloads or not according to how you see fit. But what this means is that you get a whole bunch of other benefits as well. So since we can pack all sorts of workloads onto the same machines, your utilization is generally much higher. Generally, this is that density argument, right? I can pack many more calls, services, instances, that sort of thing into a given piece of hardware, and I can let Service Fabric take care of allocating those services onto those machines so that the machines stay highly utilized and also highly balanced. I don't have hot spots, I don't have cold spots. With cloud services, you also had this problem where generally the lifetime of the code was coupled to the fact that it was running in this VM. What this meant is that your monitoring was mainly VM-centric and not application-centric. Your scaling was scaling VMs and not scaling your application or components of your application. And things were generally a little slower than you want when you did things like patching or upgrades, because you weren't patching your code, you were building whole VM images and deploying them from scratch. In Service Fabric, we get rid of that problem by separating strictly the runtime environment, the pool of resources that you have in terms of all these different machines, and the services themselves. So you can patch an individual microservice independently of all the other ones. When a microservice fails, it doesn't necessarily mean that that process or even the whole box has died. These things can be much more granular, much more finely tuned and controlled. But again, the platform has to be there to help you with things like monitoring and understanding all of the things that are going on in this environment. So what does Service Fabric really give me, right? What does it look like? Well, first of all, kind of at a base layer, it's a clustering technology. So Service Fabric takes care of knitting together a whole bunch of individual machines into what we call a cluster. It's just a pool of resources, it's a set of OSs that your applications are going to get deployed into. And these things can be anywhere from 3 to thousands of machines. But fundamentally, the cluster is the abstraction. Once you have a Service Fabric cluster stood up, that's what you talk to. You don't really have to know, or the application certainly doesn't have to know, whether or not that cluster is running in Azure or on my laptop or in AWS, for example. The next thing that we give you is a way of describing your microservices, right? So you have to tell us there are these things called services, and they have all these little components inside of them. And the three main ones that we think about are things like code, configuration, and data. Code is, of course, the executables, the actual code that you want to run. Config can be just about anything, but typically, at least if you want to use our programming models, it's a set of XML that lets you read and write different key value pairs. And data is static data, things like read-only dictionaries or icon files or other resources that are mainly read-only. But a neat thing about describing your service this way is that each of those individual packages, that code, config, and data, can be independently versioned and independently upgraded. So if you had an update that you just needed to change config, you could edit the config file and push out just that config change just for this one service. That's actually really powerful because it lets you touch only the parts of your application that you need to in order to do an upgrade. You don't have to rebuild the entire VM. You don't have to redeploy every single piece of code. You don't have to stop even necessarily the services which are running. Either they aren't impacted, or some of these things like config and data don't require us to shut down the process in order to perform the upgrade. So there's a lot of power in the fact that we understand as a platform, Service Fabric understands all these different little parts of your application. But what is that application? Well, an application is really just a collection of services, right? So you have all these different types of services. You might have a queue, you might have a transformer, you might have all these different types of things, and you want to bundle them together and say this aggregation of services is the application. And so the application is really just another layer that says it's this grouping of services with this version. And applications are interesting because each application instance, we're talking mainly about types here, but each application instance is kind of like a stamp. You can stamp out many different instances of that application and all of the services inside of it. And then each application instance is its own versionable entity. So say you had version 2 of application type A here. You've already got 3 instances of application type A running out there in your cluster. And you want to deploy a 4th one of type A, but you want this one to be the V2 one, and you want it to run side by side right next to the other one so that you can test out some stuff and have some customers maybe experiment with it and get some data. This sort of A-B side by side stuff is enabled by this application concept, and it's also very powerful. So for those of you who have been following Service Fabric for a while now, you might know that we actually announced Service Fabric as a product at Build last year in 2015, and since then there's been a whole lot of great work that's gone on. First of all, the announcement here at Build, and I'm probably not ruining it, but just in case you haven't heard yet, we're in public preview now, which is great. which means that, or sorry, we were in public preview. Now we're going to be GA'd, which is great. You can go up to the portal and create clusters, and now you can actually do that via ARM templates as well. And those clusters are hosted in Azure. That's not something that we had as a service last year. So in 1 year, we've come full circle. We've done a lot of great work around performance, scale, and density improvements. And we made a lot of changes to the API based on feedback that we've gotten from users that we think makes developing services against Azure Service Fabric much simpler and, frankly, more enjoyable. The other things that we're announcing here at Build in 2016 are we've got previews coming out for Linux support, Java support. We're going to be able to Dockerize and put your application instances inside of containers. And there's a coming preview for on-premises clusters as well, so you can take this entire environment and deploy it on your own servers, your own metal, in your own environments if you want. So what does Service Fabric really, though, give me in terms of microservices, right? Like, what does it do? What is it different than just throwing a whole bunch of code up at a bunch of bare metal servers? Well, let's take a few examples and look at how things would play out with Service Fabric. So I've got my applications. I've got two types of applications here. They've got a whole bunch of services inside of them. And I want to say, hey, Service Fabric, just deploy that for me. And Service Fabric will take those services, and you might want many of each kind of service based on your scale, and we'll throw it out into the cluster, and we'll allocate things so that each machine is pretty much evenly allocated, right? This is just the basics, and we keep track of all of this for you. There's not a lot that you, the user, have to actually do. The next thing is, let's say that machines fail. It happens, right? Maybe in Azure you get service healed, or maybe there's an outage, or maybe there's some power outage in your on-premises environment. So what does that look like? Well, Service Fabric can detect that the machine fails because we're a clustering technology. So the machine fails, and we remember what was running there. We know what services were running on that machine, and we take care of reallocating them somewhere else in the cluster and making sure that even though a machine died, your overall applications are up and running and healthy. And of course, if that machine were to come back, then we would take care of moving the workloads and distributing them back onto the machines so it's like nothing ever happened. So another thing we talked about earlier was the fact that Service Fabric has stateful microservices, which means that there is no store in the back, holding on to the state. And in a world where machines fail, how do we deal with that? Well, in Service Fabric, the stateful services have replication. That is, that changes to their state get replicated to other copies of that microservice running elsewhere in the cluster. So we have this notion of primaries and secondaries. State changes happen on the primaries and are replicated to a majority or a quorum of the secondaries. And Service Fabric takes care of all of this under the hood, right? You don't have to know where these secondaries are, how caught up they are, what operations are missing, or any of that. You just say to Service Fabric, hey, this state has changed. And you don't get an acknowledgement that that's okay until we've taken care of replicating it to the other copies of that service in the cluster. This is all transparent and under the hood for you. This brings to the point that in Service Fabric, there's really three different programming models. There's something that we call guest executables, which is really the fact that you can take any executable that you have today. It's written in Java, it's written in Python, it's written in Ruby. Basically, if it's any executable, anything that you can get Windows today to just execute, start running, you can package that up as a Service Fabric service and application, give it to Service Fabric and say, hey, please deploy this. I would like 3 copies, right? You get a whole lot of great things. You get the versioning story, you get upgrade, you get some monitoring, you get health information, and you really can just lift and shift things this way. Now, that said, lifting and shifting stuff is great to get started, but eventually you probably want to write, custom microservices, things that were born in the cloud, and that really take advantage of some of the rest of the capabilities of Service Fabric. For that, there's 2 other models that we have, reliable services and reliable actors. Reliable services are where you get, stateless and stateful services. You get concurrent granular state changes, so you can go and touch, say, one row of a dictionary or one update to a particular queue. That's those reliable collections that we're mentioning, which are really, they look a lot like standard C# data structures, but they're doing all of this replication under the hood for you. The other thing that's neat is because you don't have that backing store to do some of this stuff necessarily, you want to do transactions. You want to be able to guarantee that some state change happens in, say, 2 dictionaries at the same time, or it all fails, right? This is also where you get those benefits, and it's where you get what we kind of say is full integration with the platform. So you have the notion of primaries and secondaries, you know the upgrades, we know a lot more about the health of your application because there's APIs that you're actually implementing that we can see inside and kind of know more about the behavior of the service and whether or not things are working well. The reliable actors model is a layer on top of reliable services where you get the actor programming model. And the actor programming model has been around for a really long time. And what we've done is we've taken it, layered it on top of the reliable services, and therefore you get all of the platform benefits of Service Fabric, even if you just want to write actors. So of course we have stateless and stateful actors. You get this simplified single-threaded programming model, which is really great and simple to use, so you don't have to think about reentrancy and concurrency and all the stuff that the transactions at the reliable services layer, you can use to save yourself. And actors we think of are really great for when you want to just scale out a whole bunch of compute and state without having to think too much about how it's actually allocated in the cluster. So we see the usage of actors around a whole bunch of scenarios that are interesting, mainly around things like IoT or things when you want to scale out some unit of compute. Yeah, I want this small item that's just going to do this one job, it's going to do it well, and it's going to communicate asynchronously with the other actors in the cluster. So let's talk a little bit more about each of those two major program models. So the reliable services one is where you get the collections. And we give you two collections today, reliable dictionary and reliable queue. You can think of them kind of as an evolution of standard C# collections. So whereas collections, back in .NET 1.2 were kind of single machine, single threaded, we then gave you concurrent collections where you got single machine, but you got multi-threaded. Reliable collections are multi-machine, they're replicated, they're persisted, so data that you write into them is actually persisted onto disk as well as kept in memory. They're asynchronous and they're transactional so that you can do these atomic operations between them. And when you have these sorts of reliable collections, then you can start to do really interesting things. So here on the screen, I've got an example of a usage of 4 different reliable collections. I've got a queue and I've got 3 dictionaries. You can think of the queue as it's got a whole bunch of work that this service needs to process, right? It's got a whole bunch of pending requests that we need to process. And then I've got some other dictionaries which are going to keep track of some of this metadata. So I'm going to keep track of people, I'm going to keep track of just a list of all the customer IDs that I've ever seen, and I've got this other location information. And what I'm really setting up, if you were to think about this in terms of databases, is a relationship between several tables, right? So I've got foreign key constraints where this GUID ID that I'm generating here has to be kept in all of these places so that I know, if I get a request for this user ID, this GUID, that I can then go and look in these other tables and find the corresponding records. So this run async here is what you get when one of those stateful microservices becomes a primary, right? You're told, hey, go do work. Things are going to be showing up in this queue, which we're not showing you here, but you want to pull them out and process them, right? And so you get called run async, you get all your dictionaries and everything ready, and then you just enter in this loop where you pull things out of the queue and then put them into the other collections. And the neat thing here is that inside of that transaction block, either everything happens or nothing happens. So say you pulled that operation out of the queue, you put some of the data into the first couple of dictionaries, and then the process died or the power went out or something like that. This process will fail over, this replica will fail over, the primary will show up on some other machine, it'll wake up, and that operation that it pulled out of the queue will actually still be in the queue because we never committed that transaction. So it just wakes up, it goes right back, gets called run async, and goes right back to doing what it was doing before. So this transactional concept is actually really powerful and what helps us do interesting work, even though things might be failing or problems occurring in the actual cluster while this service is running. We'll talk a little bit about the actor model. So the actor model is, again, really good for independent units of compute and state. So you want to have thousands and thousands of actor objects, all of them executing in parallel. If actors need to talk to other things, they generally want to do it asynchronously, right? So you just kind of can send a request maybe to another actor or maybe to a reliable service. And you can do that because you've got this single-threaded execution mode. So you aren't trying to worry about what other threads are doing or what else is going on inside the actor. You're going to get a call, you're going to do that work in that one method, and then you're going to be done. Now, the neat thing about actors is that you can still have state. So inside of that one method, you can touch your actor state, you can change member variables, you can do all that, and that's all safe because it's that single-threaded programming model. The other thing that's neat about actors is that, say there's an actor that's cold. It's got a whole bunch of state and it's been doing a whole bunch of work before, but it hasn't been called in a while. So Service Fabric's programming model in runtime will automatically take that actor and dehydrate it. We'll take it out of memory and put it just down onto disk. And then if a call showed up later for that actor, we'll rehydrate it as necessary. We'll pick it back up out of disk, put it back into memory, and then hand it the method call that it needs to go do. We do this all transparently. Service Fabric's actor model is what we call virtual actors. It follows kind of the Orleans pattern where all of the actor IDs theoretically exist all the time, and that's why all you have to do in order to get one is send a message to it, right? So you just say, hey, I want to send a message to actor ID 1234, and actor ID 1234 might not exist right now, but the runtime will instantiate it, get it all set up, and then dispatch that operation into it. So, Service Fabric's been around for a while. I mean, we've been running it inside Microsoft for quite some time, and so we've got a whole bunch of, lessons and rules and things that we've learned and things that we've seen running this sort of microservices environment at scale, like in production. One of the most important concepts inside of Service Fabric is this notion of partitioning, and that's really how you get scale for stateful workloads, right? So your services, your stateful services, can be partitioned, and this is what really gives you that scaling out mechanisms. So you can choose your own partitioning scheme, and then what we do is we create all the partitions you want, and we stripe them across the machines in the cluster. We build the replicas so that each partition has the right target number of replicas, and this is a number that you can pick. And then what's interesting is, right here I've got 12 replicas packed onto 4 machines, so they've each got 3. There's not 2 replicas from the same partition on the same box. All the boxes have the same number of primaries and secondaries, so you can see that orchestration capability of Service Fabric is really working for me here. But where it really gets interesting is, let's say I add some machines to the cluster. So I add a couple machines. Service Fabric will automatically take care of reallocating the microservices in the cluster in order to make sure that, again, all of those machines have roughly the same allocation and that all of those same rules still hold, that there's no replicas from the same partition stacked up on the node. We do this automatically. This isn't anything that the user really needs to deal with, but it is there, and we find it to be actually very powerful because machines come and go kind of all the time, right? You might need to scale out because you've got a whole bunch of workloads coming in, or you might need to respond to a failure, which looks just like a machine blinking out of existence, and we have to go reallocate things. Service Fabric also has a lot of built-in tools and options for some other, production-worthy concerns. So health status and monitoring, right? How do I know, since I've got all of these microservices now, how they're doing, right? Are they performing well? Are they healthy? Are they responding to API calls? Are there any concerns or anything I need to be aware of, right? How's my cluster looking? So Service Fabric knows a lot of things about your application, about these services, and we have a lot of built-in health reporting that we use to, first of all, just give back to you in a dashboard form. We call that thing Service Fabric Explorer. And also, we emit a lot of health data into ETW channels mainly, which you can then use other tools to pick up and look at in order to analyze, say, trends or things in the cluster. The other thing that we let you do is you can kind of deal with performance and stress responses. So there's lots of metrics, there's lots of data that we collect about the performance of the actors and the services layers. And we pipe that out and let you, the customer, hook up your performance and monitoring solution of choice in order to get that information, graph it out, and kind of see what it's doing. In terms of diagnostics and troubleshooting, this is kind of the, okay, great, I've got all this data, but what do I really do with it? You can get a lot of detailed optics, so you can get recommended repairs. You can get all sorts of important events that are coming out of the cluster. Hey, this thing failed and moved over here. Hey, this upgrade is going on. These sorts of things are all instrumented and you can see them. The other thing is that you can have, of course, your own application tracing, because for certain applications, say, for example, guest applications, the platform can't see inside of those as well. But we give you a lot of tools for emitting mainly ETW, but of course you could pick whatever you wanted. And then those logs, we help you get them aggregated and emitted so that you can listen to them and pick them up with your choice of tools. So there's a diagnostics event viewer that we have shipping as a part of our Visual Studio tooling. You can, of course, look at your things inside of Windows Event Viewer. There's Azure Diagnostics and Op Insights, which a lot of customers like. We've also seen people plug in things like Kibana Elasticsearch, so ELK clusters. We've seen people start to use all sorts of different tools. Basically, whatever you're using today, you can bring it, and Service Fabric lets you hook it up to your cluster so you can get your diagnostics information out of your environment and make sense of it. One of the most important things that Service Fabric brings, I think, is this notion of application upgrade. So this is one of the things that our customers really enjoy and that they make heavy use of, right? Because I want to be doing these upgrades kind of all the time in production, really, in order to fix bugs, roll out new features, just respond to things. So I've got this cluster here. It's got 3 upgrade domains, which is a concept that Service Fabric exposes to you. So you can pick basically the number of upgrade domains you want. And I've got a whole bunch of different application instances deployed into this cluster, and they're all running on these machines. I've just deployed a new version of application C. I've got V2 of app C there. That's that bright blue one on the bottom. And what I want to say to Service Fabric is, hey, Service Fabric, please go and upgrade my existing version of app C, which is app C V1, which is that dark blue box you can see on the nodes. Please roll this out. Please go do this upgrade. And I've done upgrades before without something like Service Fabric to help me, and it's always this white knuckle ride. You always have to go to each machine. You have to try and drain the work out of it. You have to figure out some way to patch it and then bring it back up and then move the workload back on. It's always been very manual and very tedious, not to mention error prone. So now with Service Fabric, though, I just say, hey, please go upgrade my existing application. I don't know where it is necessarily, but I want you to take care of it. And Service Fabric will automatically respect these upgrade domains so that the application just kind of rolls out into the cluster. And this is great because that means that, first of all, Service Fabric is taking care of moving workloads out of machines before we do the upgrade. That's one thing. So your services don't really see any disruption. The second thing is that because of all that health information that I mentioned earlier, if, say something went bad, say I went to upgrade domain 1 and I went to go bring the application back in V2 and it didn't start, or it crashed, or I brought it back but the replicas didn't open, or the services didn't start, or anything like this. These are all health information that get exposed into Service Fabric, and Service Fabric's upgrade is actually watching for them automatically. So what would happen if something bad happened, if the upgrade was bad or had a bug, was the upgrade would just roll back. It wouldn't disrupt customers because I already moved their workload somewhere else. I would just bring V1 back, return it to its initial conditions, and say to the user, hey, this upgrade failed because this service had a problem starting on, say, node 1. Then you can go and fix the application and do another upgrade, and that one will go through. Another thing about application upgrades is that because each of these application instances is its own entity, you can do them all in parallel if you wanted. And each of them are going to follow through that upgrade domain by upgrade domain pattern. So even though you're doing, say, 1,000 upgrades in parallel, they're all still following the same rules and they're all safe. So upgrade, instead of being that white knuckle ride, turns into, you kick off an upgrade and you go get some coffee, and the alerting and the monitoring of Service Fabric out of the box will prevent anything truly bad from happening. Say something bad did happen, there's also some options besides rolling back. You can have Service Fabric just stop and pause and kind of turn things over to an administrator in order to figure out what's wrong with the upgrade and kind of leave it in its condition, which is still safe because you know that I'm only doing one of these upgrade domains at a time. So normally people have more of these, like say 5 or 10, and so you know that only 10 or 20% of your capacity is running on these other nodes while that upgrade is sitting there in that pause state. So it's great to get analytics. It's great to go grab crash dumps and try and figure out what's going on and figure out if it was just unlucky or if you want the upgrade to continue. So there's a whole lot of things that Service Fabric does around upgrade and that health integration, which are really powerful and which are pretty useful to folks. So I keep saying, I keep claiming we have all of these customers today. Who are they, right? What are some of the things that are built on top of Service Fabric today? What types of patterns do we see? Well, inside of Microsoft, there's a whole bunch of things that are built with Service Fabric today, including the core components of Azure. So when you code Azure and you say, hey, I would like a VM or I would like some networking, those services that are responsible for maintaining that infrastructure are actually built on top of Service Fabric today. Power BI, Azure SQL, Azure Document DB, Intune, Cortana, all of these things are built on top of Service Fabric and all follow basically the same microservices pattern. It's been amazing growth over the last few years, and it's been really fun seeing all these things get built at this sort of cadence, at this sort of velocity, right? All sorts of things. A great example is kind of just the Cortana team came and built something in the span of just like a year or a few months. They had some stuff up and running, and it was fantastic to see that coming because they could focus on building Cortana and not building a whole bunch of defensive code that would have to deal with and monitor and figure out what to do when things failed or how to do monitoring and things like that. We also have had for the last couple of years a private preview going inside of Service Fabric. And there's a whole bunch of companies out there that have already built a lot of great things, and I'm always amazed by what they've been able to build and to see the types of things that they come out with. I look forward to more, and of course there's ways to join the previews if you are interested. So what is the conclusion here? What are we finally trying to say? So microservices enable deployment, development, and management flexibility, right? So I can develop very small microservices tailored to exactly one job, and they're going to do it well. I also get to patch, upgrade, deploy, scale things at that kind of microservices boundary, which gives me a lot of flexibility in terms of dealing with just the realities of running a service at scale in production. Service Fabric is a platform. It's been around for a long time inside of Microsoft, and I'm very happy that we're able to give it to you folks. And it is a platform which lets you build these applications with this microservices design approach and really does a whole lot of the heavy lifting for you. And as I mentioned, Service Fabric is battle tested. We got all these things that have been built on top of it, and it's a really rich platform which you can take kind of as much or as little advantage of as you want. You can bring a guest application today, or you can write your own microservices from scratch, but it's going, no matter what you do, to help you deploy, manage, and really run these services at scale. So I hope that this talk was useful and exciting. I certainly love it. Thanks again. Now, if you want to find out more, you can go check out our SDK. You can go check out the sample code, and you can bug me if some of those samples don't work, because I help write some of them. I encourage you all to read the docs. There's a lot of actual great content out there, and it's getting better all the time. And an interesting thing that you can do is you can actually go try Service Fabric for free. It doesn't even require an Azure account. All you need is an email. We've got these things called party clusters, and party clusters are just clusters that we have a service that stands up a cluster for free for you, and you can go deploy your app to it and play and click around and kind of give it a shot, kick the tires. So that's about all for me today, and thanks again.